Okay, so have to call it example 1. So where we say sketch the function f of x is equal to 2 minus 3 cosine 2x minus pi So I will sketch it. We sketch it from 0 so equal to x. This is equal to so I'll ask you to be muted. Okay, so from 0, let's divide those over 2. And that's 5 pi over 2. Okay, so we take that root. The solution in the sketch, we did emphasize that if you want to sketch, the critical thing to have is the period, which is 2 pi over b, our b being the coefficient of x. So we have 2 pi over pi. So we have 2 pi over 2. And so the period is pi. Okay, and so if we have that, then our scale is automatically period divided by 4, so that we get pi over 4. Okay, so now what I'll do is, okay, let's just keep the question the way it is. So then we go to the horizontal shift, or the one we call the phase shift. We are looking for a starting point. Okay, so we are now looking for a starting point, the phase shift, which is sorted out by having 2x minus pi equal to 0. So we'll get x is equal to pi over 2. This is our starting point. Okay, so we can now be able to sketch. You can put it this way. So we have to start from pi over 2, going to the right until we get to 5 pi over 2. So pi over 2, we'll be adding the scale. Okay, so you have the starting point, and then you need to be adding the scale to the starting point. And any number we get after, we'll get back and add the scale again. Now be mindful that pi over 2 is 90. So if you want, we may choose to be getting it as a degree and then taking it as a radian, or we carry on with radians. So let's carry on. Pi over 2 plus pi over 4. We get 4 down. We get 2 pi. And we get 2 pi plus pi, giving us 3 pi over 4. The next number is going to be 3 pi over 4. It's going to be 3 pi over 4 plus pi over 4, giving us 4 pi over 4, which is equal to pi. Okay. And then pi plus pi over 4, we get 5 pi over 4. So we'll get 5 pi over 4. And then 5 pi over 4, 5 pi over 4 plus pi over 4. We would get a 6 pi over 4, which is 3 pi over 2. And then 3 pi over 2 plus pi over 4. Let's say 6 pi over 4 plus pi over 4. This is going to be 7 pi over 4. 7 pi over 4. And the next one will be 2 pi. Okay, so due to space, we can cut the interval in the question to just 2 pi. So we don't have to restart our question. Okay, and then look, the interval we are given in the question starts from 0. We've made it to end at 2 pi. Now, in starting from 0, we need to go back to pi over 2 and subtract pi over 4 until we get to 0. So to cover the left space, you cover it by subtracting. So we subtract from pi over 2, we subtract pi over 4, which is a 45. So we know we'll get 45 pi over 4. We subtract again, we'll get 0. Okay, now we have covered the whole interval with the x values. The remaining thing is to find the y values. So how do we obtain the y values? So we prefer to use this space here. So go back and get our function, substitute quite a good number of points, and then be able to connect the points after we have known the behavior of the curve. So we get f.
Sorry, Sam.
Yes.
I'm not clear on how the pi over 4 came in.
Okay, so we want to cover the space since the starting point was pi over 2, and we've been adding the scale. So to cover the left space, to our left, we can't add. We have to subtract the same scale. So we'd say pi over 2, our starting point, minus pi over 4, our scale. So we'd get 4, and then a 2 pi minus pi, giving us pi over 4. And that's how it comes about.
All right.
Okay, so now let's go to f and substitute 0. So we'll have 2 minus 3 cos negative pi. You understand that when x is 0, 2 times 0 becomes 0. So we have cos negative pi. Now cos negative pi is the same as cos pi, and this is giving us negative 1. So we have 2 minus 3 by negative 1 are giving us 5. So we have 0, 5. You guys should still remember that cos pi is negative 1. And so you must not get confused how the numbers are coming about. Then f of pi over 4, this is going to be 2 minus 3 cosine 2 pi over 4 minus pi, giving us negative pi over 2. But cos 90 is 0, so we just get 2. So we have a 2. We have a 2 here. And then we get to pi over 2. Pi over 2 will give us a 2 minus 3 a cos 0. Now cos 0 is 1. So we get 2 minus 3, which is equal to negative 1. So we have negative 1 against pi over 2. So we got a point there. So at this point, let's get one more. So let's get 3 pi over 4. We are going to have 2 minus 3 cosine 2 by 3 pi over 4 minus pi. What we obtain here? We obtain 2 minus 3 cosine 3 pi minus 3 pi over 2 minus pi, and that is pi over 2. Now pi over 2 is 90, and cos 90 is 0, so we get 2. So seeing that the pattern is going back, this means that at pi, we'll get back to 5. At 5 pi over 4, we'll get back to 2. We'll get back to a negative number. We'll get back to the pivot, and we get back to the maximum. Okay, so once you're able to form a complete line up the down number, your number starts going back up, then you know now you can connect. You know the numbers will be coming out like that. Even if you insisted in calculating them, they will still come out like that. And then now we connect using a curve. So we're coming from there, coming here, take it up, like that. So this is our graph for cosine from 0 up to 2 pi. Now we agreed that we're going to extend this to sec. So the extension will be ready, where we say, okay, how do we then sketch f of x is equal to 2 minus 3 sec 2x minus pi in the same interval 0 less or equal to x less or equal to 2 pi. Remember we said you always got the number standing alone. This number here, we call it the vertical shift. And all the points you obtain against that number, you put. So you know you're talking about this number here, this point here, this point, and that point. You put asymptotes. So the easiest way of knowing how to get the asymptotes. And then we haven't changed the agreement. When it faces up, ours is take it down. Ours is to take it down. So it's facing the down, we take it up. Facing down, we take it up. So it's facing down, we take it up. And we call it the f of x. So this guy in red is the f of x is equal to 2 minus 3 sec 2x minus pi. So take note that you only get to have the red graph if the question is sec. If the question is cos, we end in the green one without going to red lines. But then when it is sec, you go through the same procedure until you get to the red lines. And you have your sketch in ready. Do we have questions?
Just have another example.
Okay, that's a suggestion. Another question or a suggestion?
So I have a question. How did you find the asymptote?
So the asymptotes are placed on the vertical shift. The number standing alone, the one we call D. Because we are saying we only obtain that number when cosine gives us 0. Now when cosine gives us 0, you understand that 0 times 3 would be 0. That's why we get 2. And so when we have cosine as a 0, remember sec is 1 over cosine. So whenever it is 1 over 0, we have an undefined number. That's the more reason why we put up the asymptotes against 2.
Sir,
Hello.
how do you find the scale?
You divide the period by 4. Whichever period that you obtain.
Always.
Always. 4 sine, cos, sec, cosec. Only for these 4.
Sir,
Hello.
may you repeat on the asymptotes part?
On the asymptotes,
Yes.
you understand that sec is 1 over cosine. So when cosine is 0, sec is undefined. And the only time cosine is 0 is when we take an angle in f of x, it gives us 2. Know where 2 is standing? 2 is standing alone. So you only get to obtain 2 when cosine gives you 0. And so at that point, we are saying sec will be undefined because cosine will be 0.
Okay.
And so 1 over 0 is undefined.
Okay, thank you, sir.
Okay. Okay. So I would subscribe to having another example to clear out some more doubts. Example 2. You can sketch f of x is equal to, without any harm, we can now do something involving sine so that we also, I don't forget this, x minus pi. We'll do this from pi, let's say equal to 0. Let's say equal to x. Sorry. Let's equal to x. Let's equal to 3 pi. So let's get to our scale or the solution. We always rush to have the period, which is 2 pi over b. Now b is 1 in this case, so we just get 2 pi. So that the scale becomes period over 4, which is 2 pi over 4, and this is pi over 2. The first shift, our starting point, is obtained by equating x minus pi to 0. So we'll have x is equal to pi. Then we can immediately start once we have that.
Sir,
Hello.
like how do you find the scale whereby you are saying that say p over 4?
So p is 2 pi, the period. So the p we mean here is what we calculate first, the period. So any period you get, you divide it by 4. what you have is called the scale.
Why
So
4, sir? Can you use any number?
no, because we say there are 4 critical points apart from the starting point in the graph of sine, cosine, which affects sec and cosec. That's why 4 is the best number to be used there. And that's the formula. So we start from the first shift, the pi.
Sir.
Excuse me, sir.
Hello.
Last time, hello.
Hello.
Yes. Last time when we were finding phase shift, we are doing like negative C over B. So I'm a bit confused. What's the difference between this method you are using and this one?
They're the same.
What I think.
Hello, sir.
Hello.
Yes, last time, sir, I think I were doing one question where the first shift was 1 over 3. And the range was from 0 to, I think it was to 2 pi. And you never added the scale to the 0. So why?
Look, when there's an extension, when the first shift is inside the starting point, what do? We would subtract the scale until we get the starting point given in the interval of the question.
Okay.
But if the interval of the question suits with the first shift, we just start from the first shift going to the right to cover the interval.
Okay, sir.
Okay.
Okay, thanks.
So we get back and add. So now we have pi as our starting point, and it matches with the interval that you're given in the question. So we add the scale. So pi plus 90, we get 3 pi over 2. And 3 pi over 2 plus 90, we get 2 pi. And 2 pi plus pi over 2, we get 5 pi over 2. 5 pi over 2 plus 90, we get 3 pi. We've covered the interval. We now look for the y values. Okay, so I don't have to be writing every time how we obtain the x values. We are saying once you have the first shift, you add the scale until you cover the interval given. If you have some numbers on the left in the interval, you subtract the scale until we cover the whole interval. Okay, so let's get f and look for the y values. So start from pi. So we have 1 minus 2 sine 0. Sine 0 is 0, so we'll get 1. So we have pi comma 1, a point there. F of 3 pi over 2 will give us 1 minus 2 sine 3 pi over 2 minus pi. We'll get pi over 2. But sine 90 is 1, so we'll get negative 1. So we have negative 1 against this guy. Then f of 2 pi will be 1 minus 2 sine pi. Now sine pi is 0, so we get 1. So we go back there. So let's see what our maximum will be. F of 5 pi over 2 will give us 1 minus 2 sine as sine 3 pi over 2. We are saying 5 pi over 2 minus pi. So this is the same as 1 minus 2 sine 3 pi over 2, giving us 1 minus 2, that is negative 1 there, so we obtain 3. So we go to 3 as our maximum. So we can't even calculate the next point, we know it has to start coming down. And then we connect again. From there, we come here, yep, and end there. Should there be need to sketch f of x is equal to 1 plus 2 cosec x minus pi within the interval pi less or equal to x less or equal to 3 pi. What do? You go on the number standing alone, 1. Please, if you have a question, you can ask.
Sir, sorry to interrupt. Is the original question like 1 plus 2 sine or 1 minus?
It's 1 plus 2.
Because looking at like how you're replacing there, I'm seeing like 1
Oh,
minus 2
how we're
sine.
getting there. Okay, I get. What happened? Oh, shit. Let's go to back the question. This is supposed to be plus. So still have 1 as the starting point. So I have to draw the point. The orientation would differ. So I didn't notice that. Okay, for that observation.
Just put a negative,
Welcome,
sir.
sir.
Hello?
Just put a negative. On 1 minus plus 2 sine. You understand?
We change the question. Once there it is. So
Huh?
don't worry, we'll go through to calculate. So we're just putting a plus where there was a minus. So we have a plus, we still obtain a 1. So the point remains fixed. Then here we have a plus, so we'll get a plus. So we'll have a plus 3. So our second point goes up. And then here we'll have a plus. So still get a plus 1. Point is fixed. Then here we have a plus. So it's a plus. And so when you have a plus.
Sorry, sir, may you please repeat the process for Cosec?
So we haven't yet touched Cosec. Why not? We've gone back to the question because we used minus throughout when our question is plus. Are you following?
Yes.
Okay. So this one will give us 1 minus 2, which is equal to negative 1. So we'll have a negative 1 here, so that the other one will know it's hard to go back. Okay, so now we'll have to draw this in ready, no problem. This is not cosec, but it's the original function. So then we'll switch. We now go to the other color to look for cosec. So cosec, we locate this number here. The number standing alone, it is 1. So wherever there is 1, we put an asymptote. Wherever there is 1, we put an asymptote. Wherever there is 1, we put an asymptote. So say, okay, this one here goes up, we'll force it to face down. This guy goes down, must face up. So what are we saying? The red line is f of x is equal to 1 plus 2 sine x minus pi. And the green one is f of x is equal to 1 plus 2 cosec and not sec, cosec x minus pi. So this means that when the graph is, if by any chance you are asked on the same question, the first one is f of x is equal to 1 plus 2 sine x minus pi, and the second one is 1 plus 2 sec x minus pi. Don't think the work is easy there. You can't just proceed. You have to restart to answer sec, because it's not just the same as continuing with to cosec if you had sine. It's a different story. If you have sec, you can't just continue from sine. You have to look for cos and carry on from cos to sec. But we pick that point. That's how we sketch these graphs. So easy, so nice. So this has acted as our second example, and it's a nice one because we have seen a mixed grid. We had sine, we had cos and sec. Now we have sine and cosec. So we move to tan, and then we'll get to cot. We'll call it a day. So we should start preparing ourselves to go back to the boarding houses we were before the closure, because we may not open with the others. We may just go back to write the exams because of our numbers.
When are others opening?
That will soon be announced, since the ministry allowed that. They're opening on 23rd. Okay, example 3.
You mean we're not going to open?
We may not necessarily open. Inside the structure on its own, so it may stick to its structure of phases. Okay, so another example, we now attack the tan function. So let's start with the original tan x. So before we talk about the initial tan x, let's put up a general one. Suppose we had a tan bx plus c plus d. We would say the vertical shift, the amplitude is going to be the modulus of a. The period this time around is not 2 pi, but pi over b. So the scale is the period over 2 and not 4. Then the vertical shift is 2d, and the phase shift remains the same, and negative c over b. Take note, we've tempered the period and the scale. Okay, now these are formulas. The reason is tan has only 2 important points, and then whatever happens is just a repetition of the circles. So we go back to our question and say solution. Now for tan, we won't just get the 3 our properties like we were doing for sine and cos, sec and cosec, where we would just get the three, the period, the scale, and the phase shift. For tan, we need to get the amplitude. This case, the modulus of 1, which is just 1. We need to have the period, which is pi over b, but b is 1, so we get pi. We need to have the scale pi over 2, since we said period over 2. And then we need to have the vertical shift. In this case, it's 0. We need to have the phase shift. It's 0. And then have the sketch. So let's sketch it from, let's see, from negative 2 pi less or equal to x less or equal to 2 pi. So that we put it somewhere here, the center, move it. So we get to from 0. Remember, our scale is pi over 2. So from 0, we get to pi over 2. We get to pi. We get to 3 pi over 2. We get to 2 pi. And to cover the left space, we subtract. So we have negative pi over 2. We have negative pi. We have negative 3 pi over 2. And we have negative 2 pi. Now we can cover up the space. We go back to...
Excuse me, sir.
Hello.
What's the interval?
Given the question, negative 2 pi to 2 pi.
All
That's our
right.
interval.
I've seen it.
Okay.
Sir,
Yes.
how did you get the values of x so quickly?
The values of
X. The
we
range.
just so we went to the first shift, which is 0, and started adding the scale.
Okay, thanks, sir.
So I go back to f of x and get what it is at 0. So we get tan 0. Tan 0 is 0. This one we know. Tan 0 is 0. So we have 0, 0. And then f of x, f of pi over 2, that is 90. So what is tan pi over 2? Tan pi over 2, remember, is undefined. So undefined, how do we denote undefined? We put an asymptote. Now whatever happens at positive pi over 2 will happen at negative pi over 2. Undefined. So tan pi, that's tan 180, it's 0. 3 pi over 2, undefined. 0, 0, undefined. 0. So we sketch. Now for tan, we said we need to get everything. The amplitude, we place it there, and the negative of it. The amplitude is how far it goes up, how far it goes down, if you are dealing with sine and cosine. But for tan, the amplitude is at which point does your curve attain to the intercept, and at which point does it become free going down or up. So the graph of tan will be of this nature. When you reach there, You come here and then go down. You come from there, get here, go down. And move from here, go down. Come from there, move here, go down. Come from here, go here. This is the shape for tan. Now what you'd notice is that if tan was negative, you'd remain within the same intervals, but only change the shape. You will now be going down, to be the opposite. So it starts from down, but in this orientation, that is if it was to be negative. Okay. That's how you sketch tan. The difference between tan and cot is, so we have two differences. One, the shape of positive tan is the shape of negative cot. The shape of positive cot is the shape of negative tan. That's the first difference. Second one, the zeros of tan are the asymptotes of cot. The asymptotes of tan are the zeros of cot. In other words, we are saying the zeros of tan are the zeros of sine. The zeros of cot are the zeros of cos. So let's demonstrate an example. So we call it example 4. Let's sketch f of x is equal to 1 minus tan, or let me change here so that we see how to use that. 1 minus 2 tan x minus pi over 2. So we have a shift. Okay, let's see how it goes. So we said here we need every property. The period is pi over b, which is just pi. So the scale is going to be pi over 2. And the phase shift, we are now familiar on how we calculate. So it will be pi over 2. The vertical shift, is 1. And the amplitude is the modulus of negative 2, which is equal to 2. Okay. So I can sketch. Let's sketch from where? Let's sketch from pi. Okay, let's sketch from negative 3 pi over 2. Let's equal to pi. Let's equal to x. Let's equal to 3 pi over 2. Excuse. So we'll have our sketch. So we have our starting point is pi over 2. You add pi over 2 to take it to pi. You add pi over 2, you have 3 pi over 2. You subtract pi over 2, you get 0. Subtract, you have negative pi over 2, you have negative pi, and you have negative 3 pi over 2. What next? The next thing is that you just get at least 1 point so you can know where we place our zeros. So what is f of 0? F of 0 is 1 minus tan negative pi over 2. This is going to be 1 minus tan 90 is undefined. So we have 1 minus undefined, making the whole process undefined. So how do we present that? We put up an asymptote. So we need to get another point so we can see where we place our values. Let's do f of 90. F of 90 is 1 minus, well, there's a 2 here. So don't worry, 2 multiplied by undefined is still undefined. So we have 2 tan pi over 2 minus pi over 2. Now I understand that this is the same as tan 0, but tan 0 is 0, so we obtain 1. So we have a 1 here. So the next one will be an asymptote. The next one will be 1. So the same thing, the 1 an asymptote. And the 1 again. Now it's a stretch. So what you do is you get your amplitude, add it to the vertical shift. So you add a 1 plus 2, you get 3. Subtract 1 minus 2, you get negative 1. And use those points to sketch. Now remember, this guy is negative. We have 1 minus 2. So because of the minus, the orientation will change. You'll be starting when you get to 3, you go in between. I've missed the point, so I don't have to miss it. So you start from there. When you get here, you approach, come down like that.
Excuse me, sir. Sorry, I was asking where that 1 on the y-axis is coming from.
So the 1 is, we obtained it when calculating at 90. In other words, we are moving every intercept 1 step up. That's the meaning of the vertical shift.
Oh, all right.
So then the other one would be from here. Once you see 3, you get to curve inside. And then same thing at 3, get curve inside. At negative 1, get to curve down. So this one, curve down like that. Is that a question?
Yes.
Okay.
Where are the caves coming like this?
So because we have a negative attached to tan. So remember what we said? We said it will be positive. For positives, the orientation will be like this. Positive, we mean the tan as a positive. Then this side, the tan is negative. We have 1 minus 2 tan. So it's negative tan. So the shape would look like this. Okay? So let's see how we apply this information to a tan graph. I mean to a cot one. We call it example 5.
Sorry, excuse me, sir. Can you go back to the previous slide? Okay, thank you.
All right. So we sketch f of x is equal to cot x. So let me start with the negative cot. Solution, we treat cot the same way we treat tan. So we need to have the amplitude, the modulus of -1, which is +1, the period, that is pi over b, which is just pi, the scale, pi over 2, and what else? The vertical shift, 0, the phase shift, 0. Sketch within -2 pi, less or equal to x, less or equal to 2 pi. Let's have a sketch. So there's less work to do on tan and cot, not calculating of the y values. So in this case, we'll start from 0, we'll add the scale is pi over 2, and then pi, 3 pi over 2, at 2 pi we end, subtract, 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 and subtract. The amplitude is 1, so we have 1 and -1. The vertical shift is 0, so the points remains on the x-axis. And then what next? Calculate for 1, at least 1 point. So let's do for 0. F of 0 is negative cot 0. This is undefined. Is it? It will be negative cos 0 over negative sine 0. I mean over sine 0, just one negative. But a 0 is a 0. So we'll have -1 over 0. Very undefined. So it means that we start with an asymptote at 0. Automatically the other one will be an intercept. And then an asymptote. An intercept. An asymptote. Okay. Now this is negative cot. The one we said it will look like positive tan. So the orientation will be of this nature. That's how negative cot looks like, but you'd agree with me that these are original graphs. We've just tempered with the sign of cot, and you can see that it differs the asymptote positions with the original tan. Now we're here to see the shifted one, and we'll make it positive so that we see the difference in the orientation of the shape. We'll call it example 6.
Excuse me, sir. I have a question.
Okay.
How did you find the asymptote at 0, f of 0?
So f of 0 is undefined. Negative cot 0. Cot 0 is undefined because cot, remember, cot is cos over sine. Sine 0 is 0. So we get -1 over 0. That number is unknown. Okay.
This graph to be negative because the cos is negative cos 8.
I repeat your question. Come again.
When the graph is supposed to be negative because the cot has a negative.
So the cot has a negative, the graph would look like a graph of positive tan. That is the impact of the negative on cot.
Oh,
Yes. Otherwise, when cot is positive, then put up something else. Let's say, okay, x minus pi pi over 3. Let's do this. So this cot is positive. So that's the first thing you take note of. Then you go ahead and collect all the properties. So the amplitude, the modulus of positive 3, which is just the 3. The period, we get pi over 1, which is just pi. The scale, pi over 2. And the vertical shift, 2. Phase shift, pi over 3. So we sketch from okay, so the starting point will be pi over 3. Then we add pi over 2. So what is pi over 3? Pi over 2 plus pi over 3. We get 6 down. We have 3 pi plus 2 pi.
Excuse me, sir, I can't see the interval.
Okay, we'll put the interval. I'm trying to see which one will make sense. Then the next number, we add 5 pi over 6 plus pi over 3. We maintain 6 down. So 5 pi plus 2 pi. This is 7 pi over 6. Yes. Okay, let's fix this as our interval. So we'll run from negative 7 pi over 6 to 7 pi over 6. So I'll have negative pi over, oh, sorry, very dangerous. So the points are wrong. We've added the scale, we've added the shift here and not the scale. So the first one was correct. The first one we obtained 5 pi over 6. That was correct. 5 pi over 6. Then we must add 5 pi over 6 plus pi over 2 the scale. So get 6 down and then have 5 pi plus 3 pi. So get 8 pi over 6. So we extend it to 8 pi. extended to 8 pi. So now we come to pi over 3 and substitute pi over 2. So pi over 3 minus pi over 2, the scale. So we get 6 down. That's 2 pi minus 3 pi, giving us negative pi over 6. So we'll have negative pi over 6. The interval is subject to change. So we have negative pi over 6 minus pi over 2. We get 6 down. It's giving us negative pi minus 3 pi, which is negative 4 pi over 6. Another point. So negative 4 pi over 6 minus pi over 2. This will give us 6, negative 4 pi minus 3 pi, giving us negative 7 pi over 6. So we have negative 7 pi over 6. So our interval is subject to change. So we'll do it from negative 7 pi over 6 to 8 pi over 6. Okay. Then we sketch. So we have every other part that is important obtained as a property. Remember, we have a 0, but it's not important in this case. It does not fall in the required. It does not come by calculation, so you can just pick it. So go to pi over 3 and calculate what we obtain in the function. So what is f of pi over 3? That's going to be f of pi over 3 is going to be 2 plus 3 cot 0. And what is cot 0?
Sir,
Hello.
I have a question.
Mm-hmm.
Why are we using different values in our x-axis?
What do you mean different values?
I mean, why aren't we having, like the way we did in the other question, we had the same values but with different signs. But in this case, we have like the what could I call it? I could say the horizontal shifts. Why is it different? Like, why are we not getting the same values and replacing them with negatives on the other side?
Because when we subtract, so what was happening like in this question here is we had the scale pi over 2. So we subtracted from pi over 2. So we did pi over 2 minus pi over 2, we got 0. Meaning that 0 minus pi over 2 would be negative pi over 2. So the numbers could come in the negative form, the other side in the positive form. But in our question here, you notice that when you subtract the scale from the shift, we don't get a 0. So that brings the difference in terms of numbers.
All right.
Okay, so what is cot 0? That is cos 0 over sine 0 undefined. So we have 2 plus 3 multiplied by undefined, giving us undefined. So we have an asymptote here. That will mean the next guy will be an intercept, but shifted 2 steps up. So an intercept and asymptote. An intercept, asymptote, an intercept. Okay. And then we said you add, so add the 3. So 2 plus 3, we get 5. In fact, I can put it anywhere, keeping closer. So we get 5. In 2 minus 3, we get negative 1. And put it even here, -1. And then we'll have our sketch. Now this guy is positive cot. Positive cot looks like negative tan. So you have this orientation. That is positive cot. So please take care of the differences between cot and tan, negative tan and negative cot. Do we have questions? Okay, so if you have no questions, that is where so we only have 6 trig functions and we have sketched all of them. So the graphs are done. Tomorrow we have a class where we'll do equations and some more identities that will be coming up in the equations.
Sir, can I see the first page for tan theta?
So we may finish trig tomorrow. So I've reserved your energy. At least you have 40 minutes. You cool down, keep some energy for tomorrow, because tomorrow we'll do the whole 2 hours. Because we'll have more equations and more identities to be talked about, and then we'll close the chapter. Then we'll look at logarithms and exponentials. That's just one class. Then we'll look at calculus now. Start looking at calculus. So don't miss class. Don't miss class. It's not healthy to watch videos if you didn't attend that class. It's only nice when you attend the class and you're trying to revise. That's a revision. Otherwise, you're better off being on YouTube and picking videos. Watch. So remember that assessments are on there. Once we hit September, you may see your Moodles having quizzes, assignments to force you to start preparing for the exam, because the exam is near now. No more elections to to wait.
I thought you're buddy now.
So we should prepare ourselves. Okay, have a good night.
All right, good night, sir.
Thank you.